Earth is as far away from the sun as it ever gets. So why is it so hot? The peak of summer is approaching for those of us in the Northern Hemisphere. But as we prepare for more sunshine and sweltering temperatures, our planet is spinning at its farthest point from the sun. On Thursday at 3:55 p.m. ET, our planet reached what's called the aphelion, the most distant point in its orbit around the sun, roughly 3 million miles farther away than when it's closest. This happens every year in early July, which might sound backward. If we're farthest from the sun, shouldn't it be cooler? People tend to associate proximity with warmth, so it seems natural to assume the seasons are caused by changes in how far Earth is from the sun. But the planet's distance has little to do with it. The real reason for seasonal temperature changes lies in the fact that Earth is tilted. Our planet spins at an angle, about 23.5 degrees, which means different parts of the globe receive more or less sunlight depending on the time of year. In July, the Northern Hemisphere is tilted toward the sun, bringing longer days and higher sun angles that lead to more direct sunlight, all of which produce summer-like heat. In contrast, the shape of Earth's orbit plays only a minor role. Although it's slightly oval-shaped rather than perfectly circular, the difference between our closest and farthest points from the sun is relatively small. Right now, Earth is about 3.1 million miles farther from the sun than it is in early January when it reaches perihelion, its closest point. Compared to its average distance of 93 million miles, that's only about a 3.3% difference. Because sunlight spreads out as it travels, even a relatively small change in distance results in about a 7% drop in the amount of solar energy reaching the planet. That's tiny compared to the effect of Earth's tilt. Just how big is the difference? Let's look at a few examples. In cities like Houston, New Orleans, and Phoenix, near 30 degrees north in latitude, the amount of solar energy reaching Earth's atmosphere in summer is more than double what those cities receive in winter. Farther north, around 40 degrees, the seasonal swing is even more dramatic. Cities like New York, Denver, and Columbus see solar energy climb from about 145 watts per square meter in winter to 430 in summer, nearly a 300% difference. So while it's true that Earth is receiving less energy from the sun right now, that detail barely registers compared to the power of the planet's tilt. A slight angle in Earth's spin does far more to shape our seasonal patterns than a few million miles of extra distance ever could. In the end, it's not how close we are to the sun that makes summer feel like summer. It's how we're angled toward it.